Hello, good morning children. First, let me introduce myself. I am Jayasree and I am going to take science for you. And in the science, there's an interesting branch of science, that is chemistry. So you have already studied in the last chapter about matter and various states of matter and how one state of matter can be converted to another form. Okay, so what is matter? What you have studied about it? Please recall. Yeah, matter is anything that has mass and occupies space. And the space occupied by a matter, what is it called? It's called volume. Alright, and now the different states of matter, the matter is nothing but it is made up of small tiny particles, and based on the arrangement of particles, matter can be classified into three different states. If the particles are closely packed, you know what are they called? They are solids. And if the particles are placed a little bit far away from each other, so with less force of attraction between the particles, so we tell them that is a liquid state of matter. That is, liquids can flow because of that. And third state of matter we have studied where the particles of matter are very far away with least force of attraction, intermolecular force of attraction between them. So we classify that state of matter as gaseous. There is also fourth state of matter, that is plasma. That will be studying in higher classes. Now, the second chapter, you are going to study a little bit more about matter. Is the matter around us pure? That is which you are going to study. Now children, when you go to the shop and all, when you buy something, you always think whether we are buying something that is completely pure or not. If you are buying, suppose if you are buying salt, is salt pure salt? If you buy turmeric, is it pure turmeric? Or chili powder or rice powder or honey, sugar, whether it's all made up of pure or not. So purity is of one main important concern for everybody. So whether something is added to that or chemical is added to give the color to that substance or the food and all which when you eat it. So we are going to study what is the real meaning of purity in terms of chemistry. So children, when we go to the shop to buy salt or oil or honey and all, we'll be a little bit concerned whether we are getting the things which we are buying is pure or not. Like the salt when we buy, is it pure salt? Is there any chemical added to it? So what one main thing which will help us to identify is there is ISI mark. So based on that we know it is a branded salt and it is pure. So we can buy it. And here also when we buy oil, it is written here refined sunflower oil, and there is also mark given there so that you can understand it, that is whatever you are buying it is pure. So like that, in this chapter we will be studying more about the pure substances and impure substances and how to classify them. Now you have already studied in your lower classes, that is when we take some substances and when we add it into other substance, it will form some other kind of substance known as mixtures. So what happened, this any substance like salt which you are taking, salt, it is made up of, it is pure because it is made up of only one kind of substances in it. If you think about sugar, sugar is also made up of one kind of particles. So we can see that salt is made up of only one kind of particles, sugar is also made up of only one kind of particles, and then when we combine to pure substance, they are nothing but the pure substance. Pure substance are nothing but which is made up of only one kind of particles. Now there are some other more we are going to learn about this purity, about the different kinds of substances around us in this chapter. That is, we will be studying about mixtures, solutions, colloids, elements, compounds, and how to classify what are the difference between them. So you can see that suppose if you take water, it is a pure substance, and salt is another pure substance because water is made up of only one kind of particles. Salt is another pure substance which is made up of only one kind of particles. When we take salt and when we put it in water, and you know that it is nothing but it forms a mixture. Okay, it forms salt solution. The salt which we are taking it, salt, it's nothing. The substance which is getting dissolved is known as solute, and the substance which is dissolving the salt is known as solvent. And here it forms a clear solution. It is completely dissolving in it. Alright, so this is one kind of, so the pure salt is, it is also combining in another substance, that is water, which is also a pure substance. Another example you can see is when you take sugar and when you dissolve it in water. Add sugar to water and try to, all this activity you have to do it at home. And see it whether it is completely soluble. You go on stirring it, and then you can see that finally it will be, the sugar particles will get dissolved in water. Both are pure substances, and here it forms the mixture. And then another example which you can see is tang. All of you like to drink tang? Now I am taking a little bit of tang powder and then adding into water, and then go on stirring it. This is also, it is soluble, it dissolves completely inside the water, and then so you can see that the mixture, this forms a mixture. So mixture is nothing but a substance which is made up of more than one kind of pure substances. Now based on the solubility, or if it is soluble, dissolving in it or non dissolving in it, we can classify mixture into two types: homogeneous mixture and heterogeneous mixture. Now for example, you can see I am adding little bit of oil into this water, and after stirring it, you can see the globules of oil in it. Is the oil getting dissolved? Oil is forming an upper layer. You can see the globules of the oil in it. It is not getting dissolved in it even after stirring it. So it forms two different layers. It is forming an immiscible layer. There is an upper layer where you can see the oil, and the lower layer the water. So this kind of mixture where it doesn't form an uniform layer, it is known as heterogeneous mixtures. And here the salt solution which we had studied, it had completely dissolved, so it is known as homogeneous mixture. Now, so based on that interesting experiments, you can try out in your house, and at least 5 substances which are soluble in water and which are insoluble in water, all of you should try to do that and write in a, maintain an observation notebook and write about it in your book. Another one, you can see this is nothing but I have taken a little bit of mud or sand and I put it in the water. You can see there are two different layers. Now tell me, is it homogeneous or heterogeneous? It forms two layers, it is not completely soluble. So we classify the sand in water, it forms two different layers, so it comes under heterogeneous mixture. So heterogeneous mixture and homogeneous mixture, and that is a solution of, that is oil in water, is another example of the heterogeneous mixture. So now I want all of you to focus on to the slide PPT presentation, and then you have to concentrate on that. Please be focused, completely pay attention to that, and then let's study more about it. So children, this is the second chapter which you are going to learn, is matter around us pure. Chapter 2. So we'll go to the next part. So here you are going to study about matter, some example states of matter, mixture, what are the different types of mixtures such as homogeneous mixture, then you will be studying about heterogeneous mixtures, solution, components of a solution, alloys, and finally you will be learning about the properties of solution. Now, matter. You have already learned about matter in the previous class. Let's recall what you have learned. What is matter? Matter is anything that has mass and occupies space. So, anything which has mass means some weight in it and which occupies a space is known as a matter. So, for example, the book which you, chemistry book or any other subject book which is there on your table, is it a matter? Yes, it is a matter because it has a mass and it's occupying a space on the table. So, it is a matter. What about you? Are you a matter? Yes, you are also a matter because you have certain mass and you are occupying certain space. Similarly, the water inside your water bottle, the mud, stone, okay, chair, table, TV, all are matter because it has all those substances, they have mass and they occupy space. Then you have already learned that matter is made up of particles. So based on the arrangement of particles, the matter can exist in 3 states: solid, liquids and gases. There is also fourth state of matter, that is known as plasma state, which is made up of ions. And you know that in the solid state, the particles or the molecules are very closely packed with least intermolecular space but maximum intermolecular force of attraction. That is why solids have a definite shape and they are rigid. Another state of matter, like water which you have seen, Here, the particles or the molecules are not closely packed. They have less intermolecular force of attraction, so water can flow. They are not that rigid as solid. They have less intermolecular force of attraction between them. And the space between the molecules are not as closely packed as in solid. Another state which you have studied is nothing but which is there in the clouds, okay, or the smoke and all. There you can see the particles that make up the gaseous state. They are very far away from each other, and they have least intermolecular force of attraction between the molecules. And gas, another state that is on heating, it changes into ions. So that is the ionic state, or it is known as plasma. Okay, the light, fire, lightning, all those are that state, fire and all. It's nothing, it's not a liquid state or a gaseous state, it is known as plasma state. And you also have studied in the previous lesson that the different states of matter are inconvertible from one form to another. Solids on melting, like ice on melting, it forms water, it's a liquid state. Liquid state on vaporization forms gases, which also on ionization forms plasma. And reverse interconvertible, that means on cooling, plasma state again it changes back to gaseous state, and then on condensation gases turn to liquid, and on cooling, that is liquids on freezing, it turns back to solid. So we have studied the states of matter are interconvertible in the previous chapter. Now in this chapter we are going to study about pure substances. Is matter which we find around us, are they pure or not? So as I showed you in the beginning of the class, I showed you many things. Okay, so we have seen water, salt, oil. You can see pizza, sand, honey, cereal, sugar, flour, wheat flour and all, or the tide, surf, etc. They all are pure substances and mixture. But they, in that term, in chemically, in scientist term, you can see that they are not actually pure. They are made up of more than one kind of substances in them. So what is the definition of a pure substance? A pure substance consists of a single type of particles. A substance is a pure form of matter. So if any substance has only single type of particles in it, we call it as pure substance, like water, iron. Iron also, when you're taking it, it is made up of only iron. If you powder it into smallest particle also, it remains iron. Quartz, gold. Gold also, you can see the smallest particle of the gold also will be finally gold, that make up the bigger block. So pure substance consists of single type of particles. Next, then what are mixtures? Mixtures are nothing but it is made up of or constituted by more than one kind of pure form of matter. Like in salt solution, it's a mixture. So salt solution is made up of water and it is made up of salt. I showed you the example in the beginning. So when you take salt and add it to water, salt is a pure substance, water is a pure substance. When you mix these two, you'll get a mixture of salt and water or salt solution. So salt solution is made up of pure substances. What are the pure substances here? Water and salt. Common salt is known as sodium chloride or NaCl, the molecular formula of that. Then milk, another example of mixture. Milk also, though we call it is pure, what it is made up of? Water, fat, protein, etc. Okay. So there is a pure substance is nothing but it is also having many other particles in it. Now, this is a flowchart to show you what we are going to actually learn. So, matter, we can actually classify that as pure substances or impure substances or mixture. Pure substances can further be classified as element and compound. Element is nothing but the smallest particle that is made up of only one kind of particle. Okay, of a substance is nothing but pure substance. Whereas a compound is nothing but when it is made up of more than one kind of atoms and they are combined in a definite proportion. It forms a compound. Whereas the mixture, there are two types, homogeneous mixture and heterogeneous mixture. In homogeneous mixture, the particles are uniformly dispersed. Throughout this uniform composition will be there. But in heterogeneous mixture, the composition of the substance is not uniform. So, this is what you're going to learn a little bit more in detail. Then, examples of homogeneous mixture is a solution of, for example, copper sulfate is blue in color. When you take copper sulfate and dissolve it in water, you'll get a solution of copper sulfate. So you can see that like salt in water, it is completely dissolved in water. So it is an homogeneous mixture. And a solution of potassium permanganate. Potassium permanganate is a chemical compound. KMNO4 is a chemical formula. So it is purplish pink in color. So when it completely dissolves in water, it forms a single uniform layer. So this is an example of homogeneous mixture. Another one example is heterogeneous mixture. A mixture which have physically distinct particle and non-uniform composition is called heterogeneous mixture. Heterogeneous mixture, you can see the mixture of oil. Okay, oil and water. It is forming two different layers. I showed you that in the beginning. So it is not having a uniform composition. We call it as heterogeneous mixture. Whereas if you take tea or honey dissolved in water, you can see that it forms a single layer. So when it forms a single uniform composition throughout, then it is known as homogeneous mixture. Example of heterogeneous mixture is mixture of salt and iron filings, iron particles. Another example is mixture of salt and sand. And another example is salt and sulfur. Sulfur is a yellow color element. So this is another example to show you the example of heterogeneous mixture. Here in the first one you can see it is a mixture of oil, sand and water. And when you take three compounds and dissolve it water, you can see three distinct layers. It is not uniformly distributed. So you can see oil being lighter than water. It is on the first layer. Then you can see water and sand which is denser. It settles at the bottom of the beaker. So this is also an example of heterogeneous mixture where the composition is not at all uniform. That is it contains the physically distinct particle. You can clearly see oil, water and sand. And here another example, it is a mixture of chalk powder and water. So chalk, when you take it, powder it and put it in water, and you can see you get two different distinct physical layer. Here the water on upper layer and chalk powder which has settled down. So this is also an example of heterogeneous mixture. Now we can see the next one, that is what is a solution. So solution is nothing but, I showed you in the beginning, that is when you take salt and dissolve it in water, it forms a homogeneous mixture. It forms a uniform layer. It doesn't form any two distinct layers. So that kind of mixture is known as homogeneous mixture of two or more substances is known as solution. Solution is a homogeneous mixture of two or more substances. Now, solution has two components, solute and solvent. What is solvent? The component that dissolves the other component is called solvent. So what is the solvent over here? Yes, water is a solvent. And which is a solute? Solute is a component that is dissolved in the solution is called solute. So which is a solute over here? Salt. So how the solution is formed? Solution is formed by the mixture of solvent plus solute. So water is the solvent which is dissolving the salt. Salt is the solute. Okay, so solution is a homogeneous mixture of two or more substances. Next, which are the types of solutions which you can find around you? One common example is air, which you see around you. Air is nothing but the solution, the type of solution can be classified as gas in gas, that is different state of matter, how they combine to form different solvent solution to form solution. So gas in gas, or gas which is dissolved in liquid, or gas which is gas and solid which is there when solid particles are there in gas, then liquid in gas, liquid in liquid, liquid which is dissolved in solid, okay, or solid which is dissolved in the liquid, or liquid which is dissolved in the solid, and solid. So these are the different types of solutions around us. Now what are the examples? One main example of gas and gas solution is air. So air is a mixture of so many gases. So in that 78% of the air is nitrogen and 21% is oxygen, and remaining 1% is other gases like noble gases, dust particle. But can we identify them? Are they physically separated? So what kind of mixture it will form? It forms homogeneous mixture. So though it has nitrogen, oxygen and all different gases, noble gases, air is an homogeneous mixture of gas and gas. Now liquid and gas is perfume spray. That is the scent, perfume and all which you use. Here it is also heterogeneous. You can see the perfume, it is dissolved in the liquid state. Then solid gas, that is during the pollution type, you can see it, pollution, when it is very, very cold, the time you can see little bit of solid particles which which is present dispersed in the air, and it will reduce the visibility. In Delhi, this was the main problem during winter season. So there will be a smog formed and the road will not be clear due to the pollution. So it is also an heterogeneous mixture. To layers and all, it is visible. Gas and liquid is nothing but river water. River water has what in it? It has dissolved oxygen in it. So it is an homogeneous mixture. Then liquid mixture is nothing but rubbing alcohol. What you are using nowadays to stay safe. What are you doing? You are using a hand sanitizer. Hand sanitizer is nothing but it has alcohol in it plus some perfume in it. So it is an homogeneous mixture. Next example of solid in liquid is seawater. So what is the solid in it dissolved in that? It is salt. Different salts are dissolved in it. So it is also an homogeneous mixture. You cannot separate, you can't see the two different distinct layers of salt and water. Another example of solvent is liquid in solid, that is amalgam. Amalgam is nothing but, here you will be studying about it in higher class, it is nothing but mercury. Mercury is a liquid metal. Liquid metal when it is dissolved in another metal like zinc, zinc mercury amalgam. So it is also, we cannot see it, it is used in the battery. It is also an homogeneous mixture because we cannot see two distinct layers in it. Last one, solid-solid solution. The example of solid-solid is metal alloys. Alloys means when one metal and other metal they are melted and they are mixed together to form another this one component known as alloy to make the metal very, very strong. So it is also an homogeneous mixture. The very simple example of metal alloys are stainless steel in your house which are using it, spoon, glass, plate, tiffin box, water bottle which is made up of steel. It is an alloy because it is made up of iron, nickel, chromium, and there is carbon in it. So uniform solution of more than one or more than metals, when it is combined, it is melted and joined, and melted and it is made to combine, it forms an alloy. Next, let's study what we have learned, the properties of solution. So what is a solution? Solution is a homogeneous mixture because you cannot see two distinct layers. This is potassium permanganate in water. So when potassium small solid is dissolved in water, after some time you can see that it completely dissolves to give this color. So it is an homogeneous mixture. Now, what is the size of particles of a solution? The size, the smallest particle like salt when it is dissolved in water, what are the size of that? In a solution, the particles of solute, okay, are smaller than 1 nanometer, which is how much? It is almost, it is equal to 10 raised to minus 9 meter in diameter. It is very, very tiny. So they are invisible to naked eye. Can you see the small particles of salt? It is very, when it is dissolved in water. So the size of the particles of a solution are very, very small, which is not visible to our naked eye. Next one, third property, the solution do not scatter beam of light passing through it. Yeah, we will be studying a little bit more about it in the next part of the chapter when we learn about the colloidal solution. So here what happened when you pass a torch light through the salt solution, you cannot see the light flowing through it because it's a clear solution, light just passes through that. But when you try to pass the light through a muddy water, or you can see any heterogeneous mixture, you can see that the beam of light is so the beam of light will be scattered by the particles if the particle size is little bit bigger. So but in solution, the particle size is so small that they do not scatter beam of light passing through it. The next property of solution is the solute particles do not settle down when left undisturbed. They will not settle down. Like when you take sand and when you dissolve it in water, you can see that after some time the sand will dissolve and you can see two different layers. Sand will be settling at the bottom of the beaker where the water will be on the upper layer, as I had shown you in the example. But here in solution, you can see the picture over here. Copper sulfate, when it is dissolved in water, after some time also you can see a uniform layer. You cannot see the copper sulfate particle dissolving, settling below. The fifth property is the particles of a solute cannot be separated by filtration. In filtration, you know that we use a funnel and we keep a filter paper. And then when we pour the salt solution through that, can you see the salt getting collected over here? No. You can try out this in your house. You just make a salt solution, take a funnel if you have it, or you can in the strainer which you can use, which you use for straining the tea. You can use that, keep a cloth piece on it and take a salt solution and just pour it through that and see whether you can collect the salt in that. No, salt cannot be collected in the filter paper or the cloth because the particles are very, very small, very, very tiny. So it passes through the filter paper. But you try that experiment with another one, that is muddy water, and you can see the sand will be collected in the filter paper or the cloth, which are the cotton cloth, you can use it. Okay, so the particles of solution cannot be separated by filtration in solution. So let's see which are the 5 properties. So repeat it. First, a solution is a homogeneous mixture. The size of the particles of a solution are smaller than what? 1 nanometer. How much is 1 nanometer? 1 nanometer is almost equal to 10 raised to minus 9 meter in diameter. It is very, very tiny. That means 0 point, you put after decimal put 9 zeros and then 1. So they are invisible to naked eyes. Third property, the solution do not scatter beam of light passing through it. Fourth, the solute particles do not settle down when left undisturbed. And next you can see the particles of a solution cannot be separated by filtration. So learn those, all the 5 properties, very, very important. Let's come to the next part of this first part, that is alloys. As I gave you the example, alloy is an example of solid-solid state of matter. So what are alloys? Alloys are uniform mixture of two or more metals or a non-metal and a metal and cannot be separated into their components by physical methods. Physical method like magnetic separation. Like I told you, stainless steel is made up of iron, carbon, nickel, chromium and all. But if you take a magnet and try to separate it, it cannot be separated. Okay, and then what does an alloy shows? Alloy is not a compound, it's a mixture. It shows the properties of its constituents. So what the alloys are made up of? If it is iron, iron will show its property, nickel will show its property and all that. So it shows the properties of its constituents and can have variable composition. So stainless steel, it can be nickel steel is there, chromium steel is there. So depending on the different amount of nickel or chromium or carbon which is there, we can change the composition. It is not uniform. So it can have, that is the meaning of variable composition. Next, this is the example of alloys. So alloys, one example is brass, which will be there in your house also. Brass, this one materials will be there, showcase material which looks like gold. Okay, that is a gold plate and all, golden color plate which is a lamp and all. Lamp is nothing but bronze. So there are some metals which are made up of some decorative items in your house, like the flower vase and all are present, which is golden in color. That is nothing but it is a type of alloy. It may be made up of brass. Brass is nothing but it's a mixture of 70% of copper and 30% of zinc in it. And another example of alloy is stainless steel. Stainless steel is a mixture of iron. It will be melted, into that nickel is added, then chromium and little bit of carbon. So these all will together form stainless steel. This is an example of coins, okay, which is made up of brass and which is the main two metals are used in it. That is, more is copper, and to give it hardness, zinc is added to it. This is the stainless steel utensils which is made up of iron, nickel, chromium and carbon. So this is what we have learned in this chapter. I want you to do one small activity. Now for your classwork, what you have to do is what all I have given here, you are supposed to copy it in your classwork. Right, write it neatly, and then the activity, this will be your chemistry notes. I have written everything properly, so you are going to write what is a solution, what is a mixture, as a definition I have told you. Please write it down. And I'll be giving the test paper in your parent eye, and you are supposed to answer it. I'll be giving the answer key after you write the test. Then after writing the classwork, you're supposed to send the image to me and I'll be correcting it. Now, what are the activities you have to do it in your house? First one, what you have to do, you can note it down. You must have an observation notebook with you and you have to show to me later. Now the observation notebook, you have to write the date, and then first one you have to write, that is what are the different kind of mixtures you have to make. To make the different kind of mixtures, and you have to study, find out which is an homogeneous mixture and which is an heterogeneous mixture. Homogeneous mixture means they will not be, the substance will be solute, will completely dissolve in the solvent. It will not form two distinct layers. It will form a uniform layer. Heterogeneous mixture means when you take like oil and put it in water, you can see two different layers, or sand in water, it will form two different layers. So like that, I want you to take some material, some 6 to 7, and you dissolve it and see, try it out. Okay, so first one, you have to take salt, dissolve it in water and see whether it is homogeneous or heterogeneous. Salt and water. Second, sugar and water, Dettol and water. Then you can try with rice powder and water, sand with water, honey with water, and ujala. Okay, some color and all which you can add it in water and see that when you dissolve it, you will get a uniform layer, or and then oil in water. Okay, you can try out with different things, at least minimum 5 to 6 or 7, how much ever you want. You try out and you have to write it down, write with the date and do the activity, and then write down your observation. And you have to classify the mixtures which you are making as homogeneous mixture or heterogeneous mixture. So, hope you have understood this part of the chapter. We have studied about the pure substances. Pure substances are nothing but they are made up of only one kind of substances, particles in it, and then the pure substance consists of a single type of particles, or a substance is a pure single form of matter, and mixture is nothing but it is made up of more than one kind of pure form of matter. And two kinds of mixtures we have studied, homogeneous mixture and heterogeneous mixture. Then we had studied what is a solution. Solution is nothing but it is a homogeneous mixture of two or more substances. Under that, we have studied which are the different types of solution: gas in gas solution, liquid in gas in solution, solid in liquid solution, or solid in solid solution. And alloy is an example of solid in solid mixture. So that is very important. You must learn all those. And then finally, we have studied which are the properties of solution. Then solution, some more examples which you can see is, one I told you, that is a solution of sugar in water is a solid in liquid solution. Okay, so here that is, let's see the table which I told you here. That is, a solid in liquid solution can also be, that is an example of sugar in water. In this sugar solution, sugar is a solute and water is a solvent. Another example, a solution of iodine in alcohol. Iodine in alcohol, it is known as tincture of iodine. It is used to, it is put on to the wound. Okay, so to kill the bacteria and all, just like how you use Savlon and bacteria. When you fall down, you'll get a wound, you'll be using it. So there is another solution, tincture of iodine. So in this, iodine is solid and it is a solute, and it is dissolved in alcohol, which is a liquid. Then another example, have you taken this aerated drinks like soda and all? You have seen it. So in aerated drinks like soda, it is nothing but carbon dioxide is liquid in water, is mixed in water under high pressure. So this is, carbon dioxide is a solute and water is a liquid. So that is an example of gas in liquid. Gas in liquid is nothing but another example, aerated drinks like soda. So carbon dioxide dissolved in water is an example of gas in liquid solution. Then one more example I told you, air in air. So all of you must learn the examples of that and identify what kind of solution it is, which is a solute and which is a solvent in it. So I'll tell you once again, gas in gas example is air. So gas in liquid, that is nothing but perfume spray, or this one aerated drinks like soda. Then solid in gas, smog. gas in liquid, river water, liquid in liquid is alcohol, rubbing alcohol. And then I told you it is that is solid in liquid. One more example you can see that when I'll tell you, that is tincture of iodine. Then liquid in liquid is alcohol, solid in liquid is sea water, okay, and also tincture of iodine. Then liquid and solid is nothing but mercury and zinc. It is used in batteries, zinc mercury battery, because mercury is a liquid metal. It is a metal but in liquid state. So in that another solid metal zinc is added. So it forms amalgam. Last one we have seen alloys, which I gave you the example of stainless steel and brass. Another example of alloy will be bronze. That is the bronze medal cup and all, no medals and all, which you get after the race or the prize and all. So that is all made up of a alloy. It is bronze. So here that it will be copper, zinc and tin. Three metals are added to form bronze. So those are the example of alloys. So I've given you some work. Write down the notes in your classwork neatly and perform the activity. Write the observation of the activity in a small, another book, make it as a small observation book, and tell me the observation in my next class. So next class we'll be studying about second part of the chapter, that is how to calculate the concentration of solution, what is suspension, colloidal solution, etc. Hope you enjoyed this class. Thank you, children.